a little bit of the background of our program, a little bit of RPIs, how we fit into RPI, and what kind of experiences we can offer. What I would like to start with is that if you have questions, along the line while I'm talking, feel free to enter it in the chat box, possibly to everyone, so I can see that. And when I will get to those questions at the end. At that point, you can also speak up if the situation allows. But again, you can easily type your questions in the chat box, and then I will go through those one by one when I'm done with the little bit of formal review of what we have to offer. Okay, so with that, let me start by just reiterating where we are coming from. RPI, a little bit of the history. Yes, it definitely was founded on technological grounds. It's the oldest technological university. It was founded in 1824 in the US, and since then, one of the main profile is still technological school, engineering school, but now we have grown considerably so that we represent basic fundamental sciences as well. Physics is being one of those. A few more numbers will come along those lines, like how RPI as an institute has what percentage of engineering, what percentage of science students and research represented on campus. A little bit of history related to the department. The not so backward past. If you are in condensed matter theory, you might recall Professor Ivor Gaber, his contribution to tunneling phenomena in superconductors, for which he got the Nobel Prize in 1973. He was an RPI PhD student and subsequently a professor at RPI up until 2005, and an emeritus professor, long after, up until recently. That's just one of the most notable contribution that I can recall from the recent history. Not surprisingly, the field in physics is condensed matter. We have very strong groups in condensed matter, computational methods, and condensed matter experiments. Today, one of the strongest and largest component of our research portfolio at RPI Physics. I also want to mention Professor Heidi Newberg. She's currently a professor at our department. She's extremely active with a large group of students, undergrads, grads, and postdocs working in her group. She was part of the major discovery earlier in the 2011 that ultimately led to the Nobel Prize. Expansion of our universe. How is it accelerating? The group leaders got the main prize, and some of the participants ultimately were also recognized individually. And that kind of research, computational astrophysics, data-driven collection for astrophysical data is her main thrust of research, and she's extremely active and extremely highly cited researcher of our time. If you are interested in astro, definitely the person to reach out to. If you have any question about the particular research that she's doing, I can put you in touch with her to follow up with that kind of field-specific questions. And last but not least, I want to say a few words about our president, President Shirley Ann Jackson, who was the first African-American woman to receive a doctorate from MIT in any field, and she happens to be a physicist, and she's on the list of tenured professors at our physics department. Of course, her main focus these days are not in the current research and teaching, but she's leading the university through tough times. She's also and has been a board member of a number of scientific advisory board to previous presidents, on the board of a lot of companies. So she really is one of our leaders today in science and technology, and how to make it possible and fitting it into the working of science funding, funding and representing it at the highest levels. A few words, a few numbers I mentioned. Yeah, our profile obviously emphasizes science and engineering. That's how it was founded. Currently we have about 60% engineering students, 30% sciences like physics, math, biology, computer science, etc. Almost all the faculty that we have are research active, which is important when students are moving onto research projects, and those kind of funding is coming from external. Most often government funds. A few numbers about our physics department. We have about 24 physics faculty. 4 of those are joints, which means they are holding joint appointments, for example, with computer science, material science, just mentioning 2 examples. That's an important feature to recall, because we have a lot of interdisciplinary research. Those professors have a profile on the interface between physics and the other science. It may be physics and computer science, or physics or material science. It simply adds value to the experience that students will go through being part of collaborative teams, and also it adds value to the funding opportunities that students can have, once they once they join groups like that. Many of our faculty are distinguished fellows from APS or the AAAS or the MRS. Our undergraduate program is fairly large. At any given time, like currently, we have about 240 undergraduate students, and we have 38 graduate students. Our normal number is a little bit above that. We used to have 42, 43 in previous semesters, but of course we had to cope with COVID and what followed briefly. But I don't see any reason why we wouldn't grow back up in the next semester or so to our normal numbers, which is about 42, 43 at any given time. And I also want to mention the postdocs, which are key components of our research research scientists who are helping larger projects to make progress. They're working with, of course, professors directly, and they work very closely with graduate students and undergrads as well. I just want to emphasize again that most of the research is funded by external grants through National Science Foundation, NASA, Department of Energy, DARPA, Army Research Lab, Army Research Office, etc., etc. That's where the funding is coming from. Once students make the move after the first few years from TA to RA, these are the agencies that provide the funding, depending on the particular research group. Okay, a few words about admission requirements, but I want to underline that requirements is kind of a vague. It's a vague term. Again, we did implement a holistic approach, which means we look at the application package in its entirety. We don't have hard cutoffs in any of the individual components, but we do want to maintain very high standards overall. So we look for the potential, and we try to look for evidence that potential can be fulfilled, and that's how we are looking at our application material. So undergrad background, here is a guiding number. We do like applications around 3.2 GPA. I would put in parentheses is that I don't care that much about the particular how a little bit below is fine. If someone has 3.1, it's okay. We do look into the inside, the actual content of your undergrad course background. Especially, we do look into your upper level, junior level coursework in the key components of a typical physics curriculum, namely theoretical mechanics, electricity and magnetism, intro to QMAC at the level of Griffiths, that kind of textbook, and thermo and StatMech, and at least one course in experimental physics. Of course, individual experiences can vary, but we do look into strong foundations. So, if someone has maybe weaker grades for some unknown reason in humanity and social sciences and blew a biology 101 early in his career, and that brought her GPA down, I'm not going to be too concerned, but I would be quite a bit concerned if I were to see grades, between, D plus and C minus in each and every undergrad, core preparation courses. So we are looking not just a number, 3.2 overall GPA, but we do look into specifically into how you did in your undergrad coursework. Not necessarily because we don't believe you can do it, but we need some kind of assurances that you're going to be successful. So those students that we admit, we want them to be successful, and of course, the first steps on that path to be successful is to do reasonably well in coursework when you come to RPI. If you don't have a reasonable foundation, then there are chances that there can be difficulties, and we have to make sure that we can deal with those ahead of time. Now, in individual cases, we can do remedial courses. So if you are from a school which didn't have the typical resources, it's a small department, small program, so you may not have all the typical strong undergrad foundations in what I mentioned, quantum, electro, theoretical mechanics, and term one stat mech. It's okay. We can, on an individual level, case by case basis, we can work with the student once we believe that he or she has the potential to do some remedial coursework. It happened in the past, it will happen in the future, but we need to know, plan ahead that, okay, you have a student with great potential, but you may need some remedial coursework in term one stat mech because your program didn't offer. That's fine, okay, but we obviously need to kind of see the positive signs and the strengths of the application, and then just be aware of the missing components, which on a little by little it can be made up, but there has to be some physics foundation in your application package. Now you can see it in red. GRE general optional. Basically, RPI made it optional so that it's no more required because of COVID for the application cycle that you are interested in. It may be good news for you. GRE subject test in physics, that was a departmental requirement, and we made it optional, so you don't need that. Again, the situation can be challenging if you have for some reason very poor undergrad grades, whichever program you're coming from, but you don't have strong grades. And in those cases, students took advantage of the fact that they took the GRE test, and they did prove that they can excel. They can deliver when worst come to worst. Let's take the test and try to show that you have the foundations that is needed. So it's going to be a little bit challenging for all, because some students may have missed some opportunities to show how strong they are. A little bit weaker grades, but there is no GRE general requirement, no GRE physics. I would say this, however, that if for some reason you do have the GRE and it is strong, feel free to submit it. We will look at it. If you don't require it, but show it if it helps your case, and don't provide it to us if it doesn't. That's the point. So use these things to your advantage. Okay, it's optional. If for some reason, the GRE general is a computer home-based test, if it serves your strength, not just to our department, but you are applying to many departments, if it is to your benefit, then obviously you should show it. Take it and show it. The GRE subject test is a different beast, because that's a physical building-based test, and to my knowledge, it's not open anywhere. At least the places that I'm aware of. So as part of that test goes, if you were planning to take it at any point, it's done. You're not going to take it. And indeed, we don't expect too many people to have the GRE physics submitted, because they just don't have it. The only exception is that you might have taken it a year ago, and if it is strong, then show it to us. So it won't hurt. Again, that's, basically it's optional, means that you should only show it if it helps your case. Okay. TOEFL for internationals, yes, you need to take that. And again, that is delivered in a computer home-based fashion. So the TOEFL, you have to take the TOEFL if you're an international student and want to come to RPI, and you have to do reasonably well if you want to be a TA, because after all, you have to communicate in a classroom. So the 100 IBT is kind of the guiding score that you should have in mind. Okay, and again, I just want to emphasize that these we don't even have numbers anymore, because the GRE tests are optional. So it doesn't even make sense to say, okay, what numbers we think reasonable. Again, the 3.2 physics, the 3.2 overall GPA is just some indicator. But I personally like to look inside the actual transcript and go through the physics curriculum. That's where I get interested in the preparation and the background that each and every student would have who comes to RPI. Okay, so we look beyond the numbers. In addition to these, GPA, potentially or no test scores, we do care a lot about research experience, or maybe undergrad TA, or possibly some meaningful work experience. In general, any kind of work experience. But of course, if it has some direct ties to physics and research, it's good. And just show the evidence of that, and you can elaborate about it in the personal statement and or the resume. Hopefully, if you did some research with a professor as an undergrad, one of the letters would come from that professor. I think that sounds like an obvious choice. So you need 2 letters, I think, minimum. That's the rule. And clearly, you want to choose professor who provides strong letters. If you did strong research, yeah, you should think about asking the professor to write the letter who you did research with. Okay, so what do we offer? All our incoming students are supported by either a teaching fellowship, a teaching assistantship, or a research assistantship. I would say almost always teaching assistantship. Very rare cases where there has been a strong tie established and there is a running grant and maybe an RA, but it's a rare case. So it's almost always a teaching assistantship, and we have a limited number of fellowships. In general, it is distributed from RPI, and then we in physics can provide some recommendations for our strongest candidates, but they typically target underrepresented minorities or female students that we would like to attract in larger numbers, if possible, in this cycle and in general. So we consider everyone who fits that profile for fellowships, and out of the 10 students that we typically like to admit in every cycle, we try to have one or two coming in a fellowship, and the rest on a teaching assistantship. The numbers are clear. Again, these are just guidelines. Academic year salary 23,500 TA or RA regardless. Summer research, if you have a group already after the first summer, then you may get paid for as a summer RA, so that would total your calendar year stipend to 30,000 plus. Okay, fellowship has that's the jackpot, because then every fee is waived in addition, so all the health fees and etc. So that's a much bigger package and a little bit more money as well. Okay, so that's definitely a prestigious thing to get. As I said, normally all of our incoming students are supported by a TA, and in some limited cases by fellowship. Okay, so what do we do here? Why you do graduate school? Because you want to do something that you like, right? Which is research. But there is a path to get there, and to get to the point when you can focus on your favorite research project, and whether it's fundamental science, applied science, theory, computational, or experimental. You have to get a strong foundation. You already have to have a huge component of that before coming to RPI, right? I mean, as I said, we do look into your transcript. We want to get students, and we want to encourage students, and we try to get the students who have that preparation, because of course it's not easy. We need to know that you have what it takes to be successful. I mean, every student that we admit, we want to succeed, and yes, that implies selection, and we want it for everyone's sake. We don't want you set anyone up on a path which would lead to in any kind of bad experience or failure, whatever you're gonna call it. We want to get students who have the ability, the potential, and then again excel here at RPI. So the first step, after now you have your undergrad preparation, by the time you get here, is that our core coursework, advanced coursework. It will have, of course, the core courses and some special electives. I will say a few words about that. That will build your foundation so that you can, move on, join a group, and contribute strongly to the research project that you decided to work on. And number three, as you are picking up more and more skills, the technical skills, calculations, theory, computation, whatever, it is also important that you learn how to communicate your results at various levels, to your technical peers at conferences, or maybe at public outreach talks at high school, or maybe collaborators or funding agency personals. Again, so there are various levels of communications and the corresponding skills that you need. It involves, of course, oral, writing, and whatever it takes. But you have to learn, in addition just to having the technical skills, you have to learn how to communicate those results. And again, speaking and writing ultimately involves, okay, number one, venue, conferences, going to conferences and writing papers, right? So I mean, that definitely, by the time you get your degree, you have to have some papers. In the worst case, you have to have a couple of drafts submitted. Okay, it happens that you work a good number of years on a project, and you submit it right before your thesis defense. That's good. Maybe it's not going to be accepted. A lot of work to do, like going back and forth between reviewers. But you have to have some volume of work in writing. By the time you get to the defense, it really helps your case, and it shows that you as a researcher is credible. Okay, so again, publications, of course, are not because we just count, not by the number counting, but it shows that you contributed something to the field which is reviewed by the peers and deemed credible and sound, and in some cases very, very important and with high impact. So that's why it is important that you don't just spend let's say 16 hours a day in your lab and do great experiments, but there has to be some deliverable, and the deliverable can be, if you are in highly applied science, maybe an actual device or some design, or But if you do, let's say, theory, computational effort, or fundamental experiment, that's good too. Definitely, the papers has to show that you contributed to the field to the point that you're worthy of a PhD. Okay. Program summary. This is just a guiding number. It's a 72 credits, which will ultimately count toward your degree. Many people would stay beyond that because you keep doing some semesters of research until you complete what your advisor believes to be required, so that you get your degree. Part of this qualification process, of course, you come to RPI coursework. First step, qualifying exam. It can be waived. This is a formal exam, and it can be waived in two waves. Again, the first way is not very practical. As I said, GRE physics is optional. So unless you happen to have a GRE strong result in your drawer, in your top drawer, and you can show it to us, 700 plus, it's a reasonable score. The other way of waiving the formal written qualifying exam is that you do well on your RPI graduate core courses. Well meaning A- or better. So the qualifying exam has 4 components: mechanics, electrodynamics, quantum mechanics, and thermo and stat mech. Okay, and we do not offer classical mechanics courses, but other than that, we do have 3 core courses which you are required to take anyway: quantum mechanics 1 and 2, electrodynamics, and statistical physics. So if you do A- or A in those, then you're gonna waive the corresponding part. Okay, if you do very good in each course, then the only part you have to think about and take it as a written exam is the mechanics part. Okay. So that's the kind of the formal theory foundation, which you either satisfy by taking a qualifying exam here, or do very well on the courses and you waive it. Okay, that's the way it goes. Once you are done with the coursework and you are ready for research, which is judged by your chosen advisor and agreement what project you're going to work on, etc. After the second year or so, you're going to kind of form your doctoral committee and take the candidacy exam. Okay, which is a research readiness exam. It's not you don't have to show results. I mean, that comes after you finish your degree or defend your thesis. You have to show that you are ready. You have to make a small proposal that this is what you're gonna study in the next 2, 3, 4 years, and that you are qualified to do that, and you are capable of doing it. So that's what the candidacy exam about. Is just convincing your doctoral committee in a semi-formal fashion. Well, it's a talk, and that you're capable of carrying out the research that you're proposing to do, and your advisor discussed with you. Okay, that's the path. Can you do it? So that's what this exam is about. And when after another 3 years, let's say end of the second year, you do the candidacy exam or so, and after another 3 years, end of the 5th year roughly, you've done all what you proposed in the candidacy, and hopefully you have enough that you delivered. Have papers in preparation, maybe even published. So you are ready to write it up. You are synthesizing the little pieces that you worked on. Maybe you had multiple papers, multiple projects. You write it up in one convincing story that this is what you contributed to your special chosen field, and that's what you're going to defend in your dissertation defense. Again, this is just the key milestones that you encounter as you progress from enrollment, core courses, qualifying exam, candidacy, and ultimately the thesis defense and dissertation. So let me just again reiterate the timeline. I think I kind of mentioned it as I was explaining the previous slides. I'm not going to spend a lot of time on it. 5 years is a good average. I've seen 4 and I've seen 6, but I think 5 years is a good average that our students spend here as graduate students. There is a semi, a first order limit is 7 years. RPI kind of sets this number so that after 7 years we need to give some further recommendation, justification that why you need more. Normally it's automatically granted, but the bottom line is that and I fully agree with that the way of educating graduate students and training them is not that we keep them here for 10 years. Okay, they have to finish what they did, strong high quality work, and then move on to bigger and better places, right? That's the point. Postdoc position, industry position, labs, etc. You don't want to have grad students in the basement labs for 15 years, okay? That's not really what we have in mind. So the point of this is kind of, okay, it's again, a 7 year is not a hard limit. We can definitely change it when when individual cases justify, but there is some point on, okay, do your coursework, do your research in a reasonable fashion, and as a young junior researcher, advance to the next stage in your career. Most likely, oftentimes it's a postdoc position, sometimes it's a permanent staff member at the government lab. Who knows? Whatever is your chosen path, but you should kind of create that path for yourself and progress appropriately. Candidacy, again, as far as the time frame goes, I mentioned after the second year, sometime in the third year, to take the candidacy exam, and after that, another 3 years, you would be at the point. Again, after 5 years, you should have some idea when you're going to finish. Maybe not then, maybe after 6 years, fine too, but this is the timeline that you have to keep in mind. Quality-wise, GPA, grades, keep in mind that we want a graduate GPA at least 3.0. Even individual courses which fall below B, especially in core courses, can be cause for concern. But if you fall below the 3.0 physics GPA in your graduate courses, then there will be you will see some emails and say, okay, what's happening there. So you will be under closer monitoring, definitely, if you fall under 3.0. But that's the point. Strong preparation means that you will be ready to do well in the core courses and from then on. The rest, and I will show a few examples, core courses, electives, and then the rest will be filled with dissertation credits up until you reach what you need for graduation. After that, you just do research and the corresponding credits, as long as until your advisor thinks that you're ready to defend. Okay, so I just selected a few faces from recent and not so recent years. Again, this is not a kind of over exhausting sample. Again, it's not fully exhaustive sample. Just a couple of examples where our students ended up. A small number of students, perhaps those who did the best in their career, publishing papers in that line of operation. Yeah, so they went and became faculty members elsewhere. Notably, it's very, very competitive, and it may not be what you want to begin with. Again, there are just as exciting avenues elsewhere. Think about the rewards, salaries, etc. Which direction you want to go, how competitive it is. Casey, a recent student of mine, he was fortunate enough that he applied to Sandia and became a permanent staff member right away. After the PhD at RPI. Okay, so he didn't have to kind of circulate a number of postdoc positions, etc. But he became a permanent staff member at a leading national research lab where he's doing computational modeling of social networks and spreading phenomena in networks like that. Another gentleman, Panos Karamporniotis, he found a postdoc position at IBM. That I would say that's a typical one. If you work kind of in theory, computations, and you are aiming toward maybe a government lab permanent position or perhaps a faculty position, yeah, you have to do at least 1 or 2 postdocs. So that's the way to go. There's no way around it. Also, others might have ended up in some industrial position. Lauren went to work for Mitra. It's a defense contractor. Again, she's still there happily. Advancing on the company hierarchy. Again, Matt, faculty position at Temple. So the possibilities are manifold. Again, it depends on how good you are. Obviously, if you are doing your PhD and you haven't published anything, by the time you finish, then that may be an issue. You're not gonna probably find a faculty position because we know how competitive those positions are. And yes, people do count papers and the impact of papers and the impact of journals where you publish. So if that's your dream, that's your path, it's important that you get on that track early on. Publish papers, go to conferences, you go into a postdoc, maybe 1 or 2 after getting the PhD at RPI, and you keep publishing. Yeah, you need at least 1 or 2 postdoc positions, with strong groups, and then you have a chance, you have a shot to get a faculty position. So it becomes a bit more competitive, and yet it doesn't mean that that's the thing you want. You may really have something else in a different career path and end up much happier and fully rewarded and compensated by other means. Okay, and I'm talking about salary. if you if you want to keep that in mind as well. So there are many avenues of success, and I think our students kind of go all possible directions, and I think most of them succeed after getting their degree at RPI. So research-wise, as I said, if you do have any questions, you can email me, and I will then hook you up with the particular group leader, professor, as far as what they do, or what research opportunities they may have later on when you join RPI. I mean, just the big picture. As I said, we have astronomy and astrophysics. I mentioned Heidi Newberg, definitely the person to reach out to. Optical physics, we have in general condensed matter, but we also have optical physics. Some young faculty that recently came strengthening this direction. Condensed matter, I think, is our biggest area, which has a lot of advantages both in theory, computation, and experiment, thin film growth, etc. The good thing that if you are in that field, you have many options, which faculty, which group you may work with, so you don't have to kind of narrow yourself down early on. Okay, that's the research you do because that faculty does this. You have number of faculty working on different projects. My background, personally, statistical physics. We look at systems with complicated network structures, and we look at influencing and spreading phenomena in such networks, social dynamics, opinion dynamics, etc., cascading processes in complex networks, whether it's an opinion cascade in social networks or a cascade in the power grid. Study the network structure and what it means when you look at the dynamical process on the network. So that's sort of the main line of questioning. If you are interested in particle theory, we have a group working on lattice QCD. Professor Git has a lot of work and very intense research on that. Particle physics, we have particle experiment. I would say particle astro. It's the crossover from particle and astro. Professor Brown is working on dark matter experiments. They have projects running in Italy, in the deep inside the mountains when they are trying to find dark matter. It's very active and live. They just a couple of months ago they had a Nature paper from the project where they show evidence for dark matter. And again, perhaps linked to condensed matter, we have a lot of research, experimental and theoretical on nanosystem, thin films, nanostructures in general, and also energy research. So this is the big picture on research. Again, if you have further questions, I would just direct you to the particular group. Again, if you reach out to me, I will certainly put you in touch with them. As opposed to, I'm not the expert on the particular area. As far as resources go, at RPI I already mentioned that even our department, we have some faculty who are joint faculty. Where am I getting that? Collaboration and interdisciplinary research is at the heart of what's going on at RPI. We have a lot of research centers which facilitate professors working together on various projects, typically from different departments, and that means that professors may be from various departments, students, postdocs may be from various departments. I have, for example, long-standing collaborations from faculty in comp sci and math, likewise students. So there is really a strong experience that people can go through as getting to their degree. I've just listed a couple of centers: Center for Computational Innovation, CCI, the Biotech Center. We have Center for more material science-oriented research, devices, the Center for Future Energy Systems. Again, if you're device modeling, material science, this is the center that you may be interested. Computational stuff in general is the first two: Center for Computational Innovations. And the last three on the page, if you are in data science, network science, data exploration, it's become very current and intense. And it's ongoing at RPI. I'm involved with the Network Science and Technology Center, and we look at all kind of techno-social systems and how to model social dynamics, cascades in the power grid, etc. So it's very interdisciplinary in nature, as you can see. You can see people from physics, computer science, and math collaborating on various projects in those centers. Along the same lines, Los Alamos, just to list a couple of places where we have active collaborations with national labs or industry. Los Alamos, Oak Ridge, Army Research Lab. Again, I mentioned Professor Brown and the dark matter experiment. Professor Newberg, she's participating in the Sloan Digital Sky Survey. Industry-wise, IBM, we have extremely strong ties with IBM. We have a joint initiative, artificial intelligence and machine learning, and it's very, various departments can participate in the programs and the collaboration with IBM people. They also provided quite a bit of funding for those activities. GE, traditionally, we have strong ties with GE simply because of the spatial proximity. Their research headquarters is Schenectady, so that's why RPI researchers have a long-standing connection with them. Lockheed Martin as another example. Now, to finish it off with the last two slides, what you can do. Let's just start with the picture. In the upper right-hand corner, that's a snapshot from Troy I took, and it wasn't even that long ago. Maybe it was. I don't remember exactly, maybe a few weeks ago when it was a nice sunny day. You can see up top on the hill, that's RPI. Again, the whole point is just, on a nice day, you can stroll down, enjoy maybe a cup of coffee or have a nice lunch. And then, maybe it will take a bit longer. Instead of 10 minutes, it will take 20 minutes to go back up the stairs. But there is definitely a place to go and hang out in Troy, especially in the past few years. It really vitalized and quite and can be quite fun. In general, you may or may not have heard of, Troy is just the other side of the Hudson River. Albany is the state capital, connected by highway, so you can go from Troy to Albany in about 10-15 minutes, depending on the time of the day. Again, it's a place where you will have places if you are interested in maybe theater or other entertainment activities. Certainly, you can find places there in addition to the New York State government offices, Albany being the state capital of New York. On a good when the season allows, seasonal and temperature variations aside, definitely Saratoga, just north of us. You can go and enjoy activities in the summer, concerts, horse racing events, whatever is your interest. It's a place to go. Usually, a lot of people hanging out there. So there is some. Hopefully, at some point, life will return to normal. So maybe I'm too optimistic. And if you go there now, this is not the picture you would see. But in about 6 months, we have a chance that life will be closer to normal. So, that's why I don't mind to kind of advertising these possibilities. One thing you can always do is you go north to the Adirondacks, and you won't see too many people there. There is wilderness, real wilderness. If you like outdoors, you can find places where you won't see anyone. Okay, so if you are into that, you will have a great time. If you go north, drive north, and you can be in one of the most beautiful places on earth. I guarantee you that. So these are the things that you can do outside your lab and outside your classroom. Definitely, worth exploring. I think this is going to be my last slide. I kind of tangentially brought it up that these days we are in a different operating environment. We, of course, like the rest of the world, and the U.S. came to a grinding stop in the spring, and summertime. The university did work out a very stringent plan to reopen, and by the end of the summer, our research was back on track. So our research activities, experimental labs, were up and running with very strong rules to follow, social distancing, etc., and then testing. And once the semester kicked in early September, end of August, basically the whole testing system kicked in. And you can see at the bottom of the slide that how many tests RPI concluded in the last 3.5 months since August 1st, and what's the total positive tests since then. We have 21 total since the last 3.5 months. That's an extremely small number. Considering that we are not isolated from the rest of the world. We live in Troy, and we don't live in a lockdown, but there is an extreme strong set of rules that we follow as far as social distancing and the testing. Okay, so you can see that the testing basically made it possible that we have somewhat resembling a campus life, even as today. And yes, we acknowledge that probably it's going to be very similar next semester in the spring, but we are also hopeful that by the time summer comes and perhaps early fall, our academic campus life is going to look much more like what we had before, as opposed to what we had in the summer and the spring and even now. So yeah, we are in full operation, well, with some reduction, of course, who is on campus and what kind of rules we follow. But other than that, we hope that we can approach a true academic in-person environment in the months to come. Right now, yeah, we have classes which are in person, but it is limited to size. We have researchers who are on campus in person, but they have to follow very strong density requirement, how many people can be in a lab, etc. And they have to go through very stringent schedule of testing. Currently, all of our students who are on campus in person, they have to be tested every 3 days, I guess, twice a week, something like that. I think that's a fair statement to say. So at least twice a week. Okay, so with that, I pretty much finished, and I saw that there are already some questions there. So I think what I will do now is that I will just consider the chat box, and if you have any questions, type it up there, and I will try to address those. Okay. Okay. So internship-wise, I would say instead of the word internship, I would characterize them as research opportunities. So some go to work for a company. We have, in fact, in the group where I have a lot of collaborators, computer science, it is very common that in that field, data science, and a lot of physicists work in data science can find summer internships working for Google or Facebook. And then they even find permanent jobs after that in some of those companies. Some students, and I wouldn't call that internship, but summer research opportunities may find positions in government research labs. Like I had some students in the past when I had some close collaborations with researchers at Los Alamos, and then they spent 3 months there during the summer. So it depends really on the project, the group, and the connections of your research advisor, that which place you have a good chance to apply. Of course, you can apply to any summer research position at Facebook or Google, if that's your specialty, data science and let's say machine learning, and applying it to social networks or whatever is your research area. But of course, it helps if the group and the advisor has some recognition in that field, perhaps even connections, so they know that students coming from that group will do well. Yeah, so we had examples for that. But again, there is another aspect when we wouldn't call it internship, and instead of going to some industry, we would go to national labs, and that exists too. 2 to 3 months summer research. So any more questions?
And you can feel free to unmute yourself and ask a question if you have one too.
Hi, can you hear me?
The application deadline is going to be January 1st. And all you have to do is have your application submitted by that time. So in order to submit your application, you have to have completed the online application, include the information for your recommenders, attach your personal statement and your resume.
Great question. Someone is asking, do we need to have a TOEFL if you have a master's degree from the US? No, if you have an accredited US institution that is giving you the master's degree, you don't need a TOEFL.
Just to add on to that, if you have graduated from that U.S. institution within the past 2 years.
Got it. Yeah,
so
thank you.
If you graduated in, let's say, 2017, that's not going to be valid, and you would have to take the TOEFL.
Yeah. Yes, so basically you can absolutely submit the unofficial one, and it is okay that you only ask to forward the official scores when you actually get some decision. Okay, so it's okay to start with the unofficial scores. Just make sure that you enter the numbers, and you can actually upload a copy of your thing. But ultimately, if you were to accept admission, then you have to provide, of course, the official version as well. Okay, how many number of application do you receive? So last year we got about I think about 150. That's how many applications we get, and of course we have to work with our yield. So as I said, our target number, depending on the budget and the details of the year, we want to have about 8 to 10 incoming graduate students supported by TA positions, teaching assistantship position. And what it means that we typically offer, working with our yield, we make about, I would say 30 to 40 offers depending on the year, and then depending on the responses we may add more, and so that's how the numbers work out. It's the quality of the application which is the key. So again, it's always easy to kind of sort out weak applications, and then the point is we want people who have some strong background and the potential. Again, it's not an issue if you miss this or that little piece in your undergrad preparation, but of course you cannot miss all, right? I mean, if you did horribly bad in every course, that's a different story. But really, if you missed a little coursework here or there, there are ways to make up. That's good, but you have to have some strengths of your application as well. And then we go through those. As I said, we don't just rank them. Even in the past, when we had GRE, we didn't just rank the applications according to the GRE score. We're not going to rank the applications according to the GPA. Yeah, I do keep an eye on the GPA, the overall GPA, but I do look inside, and even more so, I look at the actual performance in I would say physics courses of the core, mechanics, quantum mechanics, electrodynamics, and thermo and stat map. Okay. So I think when you submit your GRE, yeah. So I answered that. How many number of applications? I answered that. What's the page limit? I would say maybe 2 is a good number, but 3 is fine too. Definitely not 15. Okay, so no one will read 15 pages. If you write 3-4 pages, that's okay too, right? I mean, so I would say keep 5 as definitely the upper limit. Okay, so and it should be more than 1. So that puts you into the longer than 1 and less than 5, and find the one that you can fill with meaningful listing of your achievements, right? Why you like physics, what you want to do when you come to RPI. And I think it's always good if you're not infinitely broad, but not too narrow either, right? I mean, it has to kind of show that you have some interest which would tie you in very well to the research that is going on at RPI. So if you say that you would like to study, let's say, quantum gravity in 16 minus epsilon dimension, and that's all you want to do and nothing else, that's a tough call, because we don't have anyone who is doing that kind of research. But if you do that, you're interested in, let's say, fundamental theory, maybe computational method, yeah, we do have researchers who are doing QCD. In other words, give yourself a chance that you do not narrow your interest down to such a small area that no one is doing that at RPI, at least. And you also don't just want to say that, okay, you want to do physics, because that's a bit too broad. So make sure you do your research. First of all, you should know what you like, right? So make sure that you really know roughly what area is your interest, and then do a little research. Just see what professor is doing what. It's very well described on the RPI web page, the different groups name, and you can just say that's the area that you love. Perhaps you even did research in that area, maybe some other area, but kind of tie it in that's what you would like to do at RPI. and it definitely is something that shows that you read what kind of research we offer. Again, you don't want to keep it infinitely broad, and you don't want to make it too narrow that you exclude yourself from any meaningful consideration. Okay, how has the department been able to maintain stable? Actually, the experimentalists had a little bit of hard time in the summer because it's not that easy to run the experiment. So they had to focus on things that can be done in that environment, namely, writing papers or checking data. Again, you can always work with data no matter what. But as I said, once that really first challenge of resuming campus reopening was done, our experimental research is back on track. So if you need to work in a lab and you need to produce numbers, I mean, students are working in the labs and postdocs as well. So the funding really didn't have a lot of either way, it was not really impacted whether you get it's always tough. Okay, getting funding is really challenging regardless of COVID. It was probably a little bit challenging to actually get the research done that you had money for in the summer, simply because you couldn't go to your lab. But after that little time was over, spring and early summer, the various projects and the leaders and the students were able to get back to campus and kind of continue research. So I think if they had funding, they maintained their funding, and maybe there was a little bit of delay with output and deliverables, but COVID didn't put a huge impact on that in either way. Now, on the positive side, there is the kind of research which got an enormous boost out of COVID. Anything which involved, for example, modeling of epidemics in various communities, networks, colleges, cities, etc. Data-driven science, and RPI is utilizing that as we speak. But of course, not just RPI. Many other universities are having programs to model the control, the mitigation, the prediction of COVID. It's a collaboration between math, computer science, physics, whatever. So definitely, it gave a huge boost. And at that point, it's just what I have some closer ties within my research. Of course, if someone is involved in any kind of biotech medical research, there can be an enormous boost of the opportunities that actually this challenge brought, basically how to solve problems which will fundamentally impact the lives of hundreds of millions of people. Okay, so any bound on the IELTS scores? It's an excellent question. I might even look into that. I think it was on the. I know the TOEFL numbers were 100, and we had some guiding numbers on the IELTS, but I don't want to say something which is completely wrong. Let me just look up some of my notes, because I might recall some values, and then I'm not going to tell you something which is off by a large amount. So I think the IELTS, to give you some rough number, is around 7. Okay, so that's the IELTS value, that kind of the suggested minimum. Okay, so I would say I cannot recall it by section, but that's a guiding value, 7 or so. What if someone is currently a graduate student in the US? Does he still? Well, I think you have to have a degree from the US to waive yourself out of the TOEFL. Is that correct, Jared?
Yes, but if they're applying for fall, for the fall semester, and they are going to get their master's degree in, let's say, May or August, that is acceptable. But that's only if you're going to be graduating in May or August.
And what if someone, and I'm asking this just because I want to make sure I don't answer anytime something which is off. If someone is in the US and working for a degree for 2 years but never completes the degree, then they need to take the TOEFL, right?
That's correct.
Yeah. Okay. Okay. So do we need to mention the names of the specific professor? Again, don't be too specific or this or that, but you can mention a number of professors that you are interested in, thin film research with Professor Wang, but also interested in possibly computational condensed matter, Professor Zhang. So yeah, you can definitely just mention a few names, and again, just what you can read on the website, excuse me, and what you can learn from there. What if someone completed core courses in his matter? Does it still need to take individual? That's basically individual level determination. On a case by case basis, what happens is that if you believe that you already have the graduate level core courses, one or more, then once you come to RPI, you get in touch with me. I'm the graduate program director. Well, I don't know whether I said that, but I should have introduced myself properly. I forgot. But basically, all the administrative part of this thing runs through me. And the way it starts is that you just meet and you discuss what coursework you think qualifies as your graduate core course, and then wherever you took it, and you need the transcript, and from that institution you have it already, and we need the syllabus, that course for comparison, and then we're gonna propose that you either waive that work, which means you don't have to take it, or you might even transfer those credits. It depends, but either way, you do not necessarily have to take the graduate specific core course if you already took it somewhere else. So yeah, we have, quite often someone comes in, whether in the US or elsewhere, they attended, a master's program, physics or not, and maybe, they took one course which was exactly aligning with what we call core courses here. So yeah, you can either transfer those credits, or you can waive the corresponding requirement. Either way, if that's a good match, you don't have to take it here. Okay, what are the duties of TAs? Usually, fundamentally, they involve in two kinds of activities. That's the typical one: teaching in labs in undergrad introductory classes, Physics 1, Physics 2, or grading either in that course. And again, it's an and/or. If you are assigned to an intro undergrad course, you're going to do some grading and you're going to run some lab sections, or you may be the TA for a more advanced physics course taken by our undergrads, let's say theoretical mechanics quantum, and that involves a lot of grading, office hours, and some courses running recitations. Again, sort of I think our TAs who are really good communicators and good educators can also be part of some recitations if the particular course instructor decides to do so. Hours wise, the nominal TA assignment is I think 20 hours. I would say normally it depends on the person and the fortunate or how lucky you are with your assignment. But now the point is that it never goes above 20 hours, but depending on the semester, yeah, I mean, you can have something which may run to 16 hours a week or 12 hours a week. It depends on the duty, and 20 hours is the nominal limit that your assignment can carry. What do you normally do when an applicant has to take a majority of their core upper class physics courses during the final year? It's a good question. I mean, hopefully there is something to look at before. So it's good to see that you're going to get those core courses underway. But in that case, you still have core courses which you had some intro courses, and maybe you had some kind of intermediate one, physics, maybe quantum physics 1, quantum physics 2, something which shows that you have you have the strength and the determination to manage coursework. Okay, so yeah, that in that case we may look at what you have with grades, and then we may we might look into to the grades, because yeah, it may be that you will get the grades posted later, but I would say I would definitely be interested at least what the grades are for the courses that you completed in the fall, and then we could see what's in progress in the spring. So yeah, what you can do is that submit what you have by the deadline, but if for some reason those transcripts do not include the grades for the fall, then you can reach out to me and then just send me a transcript. You can send it to me where we can look at that. Okay, what are the actual fall completed grades for some of the courses that we are talking about? Okay, master's degrees pending. But my BS is complete. Actually, you don't need a master's for a PhD. So, some students may have a master's for whatever reason, but, what you need is a BS that you have or will get by the time you would get to RPI. So, most students are kind of getting their BS sometime in May or in the summer. So, and, that's sort of the standard thing. And of course, when you actually enroll RPI, you have to show evidence that you completed your BS. But, that's what you need. Sort of a tentative BS that you will get by the time you come to RPI. MS, you may have an MS degree, but that's not required. I mean, if your MS degree is highly relevant, it can have your case. If some courses overlap, that's great. You may use some of those, but that's the master's degree is not a requirement. So, it certainly shows that there is extra information that we can look at, and that is to your benefit, especially if you do well in that program, because then, once that's the case, we need your transcript from the masters, and we're going to look at that. That's fine. I mean, if you're graduating with a master's in the fall, that means that you will submit transcripts including grades, but not the degree completion. I assume you still have a lot of courses being part of that master's program, but it's not going to show the grades for those which are coming. But whatever grades and whatever courses that you have underway, by the time you apply to RPI, that's what the transcript will show. Yeah. Again, the key is that you have a master, you have a BS degree when you come to RPI, and then you will deal with the logistics. I'm not sure what's the logistics if you come to RPI as a let's say in the fall. I'm not sure what the relationship of that with regards to completing your masters in the fall, because if you are here in person in the fall, that means that master's is online. So I cannot judge it from the question, but that is something which has to be worked out, I think, on your end. I mean, clearly, if you come to RPI and you're starting in fall 2021, that means that you're gonna be on RPI campus, at that time. So how you deal with completing your masters in that fall is something that that is gonna be your task, and how you work it out is the masters. Okay.
Any other questions?
Yeah, I think earlier someone asked the IELTS score. I don't have a breakdown on the various components. I think on the TOEFL, it might some be on the general RPI page, but the point is for the TOEFL IBT, we need 100 and above. And the IELTS, let me write it in the chat box, IELTS, I think it should be kind of the suggested minimum. That's a good word to use. It's 7.0. It's the total band. Okay, so we think that's okay, and I think for likewise for the TOEFL suggested minimum. Again, I would say IBT, right? It's a bit more than because students coming in for a TA position, so it's 100. Again, if you are 1 point short, okay, but with a TOEFL of 82, it's hard to convince us that you're going to be able to communicate effectively and successfully in a classroom where you may be assigned as a TA. So So this 100 is since everyone who is coming in is most typically will be supported by a TA position. This is what you need. So for you to get that admission and support, which go together in almost all cases. Yeah, I mean, it's good. You can change. It's great. Basically, let me just read out this question because I missed it, so I don't have an explicit relevant. You don't. That's fine. If you are interested in high energy physics, and you want to do something else, that's perfectly fine. It's not like you need to have experience in one field in order to be able to come to RPI and work in that field. It's just you have to have some. Let me put it this way: some genuine curiosity-driven approach to physics. Okay, why that you have to like physics, you have to be interested in it, and it's fine that you did this, you read about that, you really love theoretical high energy physics, and you maybe talked about it, worked with someone, collaborated, but what you learn as a result of that is that what you want to do maybe is condensed matter, because that's where you think you can change the world. Okay, so it's all good that you studied fundamentals, etc., but now you realize that you want to do something more applied, and condensed matter is the venue where you can make it happen. So that's perfectly fine. It's good to have a story, right? Why you like physics, and what made you interested in physics, and what you did in your undergrad years, and how you think you can contribute in the best possible way to your own progress in physics and to our program at RPI.
Any last questions before we conclude the webinar today?
And as I said, I just gave a very general overview, high-level overview of the program. Definitely, graduate school is about research, and if you have any more specific question about research, specific groups, feel free to reach out to me. In the very first message that you received advertising the webinar, you can find my contact information, so you can reach out to me in email, and I will put you in touch with the professor or group leader that is the one in question that you want to learn more about.
All right. So, Professor Cornish, I want to thank you again for doing this, and I want to thank everyone for joining us today.
Yeah, thank you all indeed.
Yep. If you have any other questions, please feel free to either contact myself or Professor Cornish, and we will be more than happy to answer those questions for you.
Thank you, Jared.